Move on to step 2 of our LaCroix volume of liquid in each can. And step 2, let me move this. Step 2 is going to be our planning stage. So step 2 is where we plan. And how we're going to plan, again, taking a look at my reference sheet. I've got my null. I've got my direction of the test. That's my step 1. I've got all my information. And now here's the planning stage. I've got to make sure I check the central limit theorem. So we've got to see, can we use the central limit theorem? And so I'm going to use the central limit theorem to find the distribution. The distribution of the x bars. So what are our requirements? Again, they're back on that reference sheet that you need to make sure you're familiar with because you're allowed to use it on any exam or quiz. So my requirements are a simple random sample, and they said the cans were randomly selected, and we weren't given any reason to think it's not a simple random sample. The second thing is either your n has to be bigger than 25, which it's not. Our n is 12. But the way we can get away with this is also if you look at the shape of just these 12, it looks like it's forming a normal distribution. And there's nothing in the problem that says the population isn't normal. So we're going to assume that the population is normal. And then the last thing that we need is for the population size to be 10 times the sample size. In this case, n was 12. So we need our population. So LaCroix is a pretty popular brand. So I'd imagine all the cans produced in one day, I would imagine that would be greater than or equal to 120 cans. I think that would work. So make sure you tell me that you know what the population is. It's all the cans produced in that day. So the big deal now is the fact that because we know the central limit theorem is in play, so by the central limit theorem, and remember now we also know because sigma is unknown, and when sigma is unknown, we know that the t distribution is going to be a better estimate for the x bars than the normal. So the x bars will run by a t distribution with a mean that's the same as what we assumed in the null hypothesis. So they should be centered on 355. And then they'll have a standard error. We got to go hunt for that standard error. The standard error is going to be sigma over the square root of n. Well, we don't know sigma, so the best thing to use for it would be our sample. We're going to approximate sigma with our sample standard deviation. So we're going to use 2.19 over the square root of 12, and we get 0.63 milliliters there. So I'm going to put 0.63 in for my standard deviation. And remember that the t distribution also has what's known as degrees of freedom. So degrees of freedom, n minus 1. So in this case, it's going to be 12 minus 1, which is 11. So we've got that third parameter that we need to know, and that is the degrees of freedom. So now, based on this, we know how the x bars behave, and that's what we're going to use to find our p-value in the next step.